If you bought an AMD R9700 to run local AI on Windows and you're staring at malformed garbage output, a black screen, or a driver that just won't behave, this video is for you. I'm going to walk you through the exact Windows setup that finally worked on our mini PC, including the trap that ate a whole weekend and the context-size mistake that crashed the card hard enough to trigger AMD's bug report dialog. Stick around because the fix is not what most tutorials tell you, and the numbers I'm about to give you were measured on the real hardware, not copied from a spec sheet. Most local AI content assumes NVIDIA and CUDA. You plug in an RTX 3060 12GB or a used 3090, install the driver, and it mostly works. That path is real, and if you're on budget CUDA hardware, stay on it when it serves you. The R9700 is different. 32 gigabytes of VRAM for a serious value play if you don't want NVIDIA's premium for the same memory class. The catch is, the Windows AMD path is rough. This guide is for normal people with limited resources, affordable CUDA, and budget non-CUDA alike, who need the honest path, the trade-offs, and the failure modes, not marketing. Let's be concrete about the card. The R9700 is a 32 gigabyte class accelerator. That's enough room for a 27 billion parameter dense model and even a 35 billion parameter mixture of experts with headroom for context. Memory bandwidth drives tokens per second more than raw marketing flops. And it's AMD RDNA architecture, which means ROCm for compute, not CUDA. That single fact is the root of everything you're about to learn. If you understand that going in, the rest of the setup stops feeling random. So what actually goes wrong on Windows? The most common symptom is malformed output, garbage tokens, loops, repeats, or the model dying mid-sentence. People also hit black screens and hard crashes. The instinct is to blame drivers, the model file, dual GPU wiring, or maybe context is too high. We chased all of those. Two findings mattered most. First, the backend some tools default to on AMD. Second, pushing the full native 262,000 token context on a driver that cannot hold the VRAM ceiling without falling over. Trap number 1. On Windows, Unsloth Studio can default to a Vulkan backend for AMD graphics. Vulkan is a graphics API that can do compute work, but it is not the stack AMD designed as the durable machine learning path. On the R9700, that Vulkan path is a real problem for sustained local inference. In our world, it meant malformed output, and it has been a crash path. If you're dual card and everything looks cursed, do not start by rewiring PCIe topology. Rule out Vulkan first. That alone will save people days. The fix that worked for us is simple to say and easy to miss. Get off Unsloth's Vulkan path and onto Ollama running ROCm. ROCm is AMD's native compute stack. Think of it as the AMD side cousin of CUDA. Once we switched, the 35 billion parameter model ran fully resident on the GPU, clean text, stable resonancy, and real tokens per second. If you're seeing garbage tokens, do not reinstall drivers 10 times before you check the backend. Backend first, driver second, fancy dual, GPU experiments third. Drivers still matter, and this is where people waste evenings. Do not treat Windows Update as your only source of truth for a compute card. Go to AMD, grab the Adrenalin package that matches your card and Windows version, install it cleanly, and reboot. Not later, now. Then confirm the R9700 is the active device your inference stack sees, and that ROCm is actually visible to the tools. If an app cannot see the card, 9 times out of 10 it is PATH, a display driver grab, or a generic driver that is wrong for compute. Before you load the big model, prove the stack. Load a small model, run a boring prompt, confirm clean output, only then pull in the 35 billion parameter MoE. That sounds obvious, and it still saves weekends because debugging a 22 gigabyte resident model is the wrong place to discover your backend is broken. Start small, confirm the pipeline, then scale up. That is the professional order of operations. Here is what we measured on the working path. Qwen 35 billion. The A3B mixture of experts, fully on the GPU at about 22 gigabytes of weights. Once warm, speed lands around 78 to 87 tokens per second on our rig. The stable working context we locked is 131,000 tokens, 131K, with zero CPU offload of the weights. Those are measured numbers on the actual Mini, not brochure numbers, and they are the ones you should treat as the practical target on this driver. Now the correction that matters. The model can advertise a native 262,000 token context. We loaded that. It ran briefly. Then Windows died. System bug check. AMD black screen crash dialog after reboot. At 262K, the key value cache pushed total VRAM to about 27.4 gigabytes out of 32. Near the ceiling, this driver fell over. So if someone asks, "Hey, is it 131K? Am I wrong?" The answer is no, you are not wrong. 131K is the largest stable window we verified. 262K is model capability. It is not a safe daily setting on this Windows driver path. Full honesty on the hardware path. Our R9700 runs through an OCuLink external GPU dock on a mini PC, not seated in a desktop motherboard slot. OCuLink is close to PCIe bandwidth, but it is not identical. If your card is in a native desktop 16-lane slot, your speeds may differ. Often better. Often better? Every tokens per second number in this video is from the OCuLink path. I am disclosing that up front so nobody treats our chart as universal law for every chassis. One more honesty note, so you do not panic. The first load has to read about 22 gigabytes from disk onto the GPU. That cold start can look like 1 or 2 tokens per second, and it feels broken if you have never seen it. It is normal. Once the model is resident and warm, you get the real 78 to 87. Do not judge the card on the first load after a model swap. Give it a warm pass, then measure. That single habit will stop a lot of false "my GPU is dead" conclusions. If you are running dual R9700s, like one of our viewers, hear this clearly. Malformed output is still usually the backend first, not the dual topology. Get onto ROCm. Prove one card stable at a sane context. Then chase multi-GPU. Dual card wiring is a real engineering problem, but it is the wrong first debug target when Vulkan versus ROCm is still undecided. Eliminate the easy villain before you dismantle the whole case. Quick practical checklist. Backend, ROCm, not Vulkan. Drivers, Adrenalin from AMD, not a random Windows update package as your only plan. Context. Start at 131K on this driver, not 262K. Garbage tokens. Switch backend before you rewrite your whole stack. Black screen or bug check under huge context. Lower context and retest. Painfully slow first run after a swap. Cold load, measure warm. Device not found, PATH, process environment and which GPU is selected. Save that list. It covers most of the pain we actually hit. Whole thing in one pass. Buy the R9700 for the VRAM value if that is your budget lane. Install Adrenalin cleanly. Prefer Ollama ROCm over Unsloth Vulkan on this card. Expect about 78 to 87 tokens per second. Warm on our OCuLink path with the 35 billion MOE. Treat 131K as the stable working context, and treat 262K as a crash risk on this driver until AMD or the stack changes that fact. Disclose your eGPU path if you have one. If this saved you a weekend, hit like and subscribe. Drop your GPU and model combo in the comments. I read them, and your failure mode might be the next video. That's it for this one. This is BizFlow AI, real local AI on real budget hardware. Honest numbers, warts included. We show the crash, not just the highlight reel. Thanks for watching, and I'll see you in the next one.